Hello everyone. Today we'll talk about the solution to the problem longest happy string. In problems like this, where we have to create as long a sequence as possible from some available building blocks, and we have to satisfy some conditions, there is a common pattern that often works and allows us to solve a problem in a greedy fashion. And probably the easiest way in which we can use that pattern is if our blocks are symmetrical. That is, all the rules that we have apply to all the letters or combinations of letters in the same fashion. In particular, if all the constraints are, as here, just about a single letter, then it's even easier. And the intuition to solving a problem like this is that if we have those constraints be symmetrical, then we have the most options available if we have about the same number of all the letters. And this then leads us to a solution that gives us some, let's say in a sorted array, we have some number of occurrences of every value. Of course, here we only have 3 value types, but I'm talking generally. And in order to make all the values as equal as possible by only taking away values, we should always take the values from the highest downwards. So there are maybe some different types of values. And it applies to this problem. In this problem, we know that we have the most options when we have about the same of all the letters. In that case, we probably can use all the letters. In fact, if we have the same number of all the letters, we for sure can use all the letters, considering this specific set of conditions. And so the only thing that remains for us is to implement our greedy, which will allow us to select the appropriate letter, so the letter which occurs the most, as the next step. And of course we have to remember to maintain those conditions. We could use a priority queue, and if we had many different types of building blocks, we should use a priority queue, but in this case we may just do with a list that will sort whenever it's necessary. So, we'll have a list that will tell us how many times each letter is available for us still. This is the list avail. And we'll be creating our string. In Python, to create a string, you should create a list, because strings are immutable, and at the end create a string by joining all the characters in your list of characters with empty strings as joining material. So essentially empty string.join and your list. And so we'll be having an infinite loop from which we'll break whenever we cannot add any new letter to the end. In every step we want to take the letters that appear the most, so we'll sort our array. And so we're sorting in a loop, but the array only has 3 elements, so this sorting is just a way for us to not implement some weird stacked if statements to decide which of A, B, and C is the biggest, the second biggest, and so on. We can just sort this small array. And we want to use the letter that appears the most often. So we just take the letter that appears the most often. Of course, if that letter doesn't appear at least once, then we have no letters available, and this is when we can break happily. And the only problem appears if actually the 2 previous letters were exactly this very same letter. And again, in the spirit of trying to make the number of occurrences of every letter the same, we should take the letter that appears the second most often. So we can, again, take the second letter from our list, leaving us with only the third one on it. And now again, if we do not have access to that second letter, we cannot make our string any longer, because otherwise we'll break this constraint. So we have to break out from this loop. Otherwise, we append one of this letter, and then append our original most common letter. Or if we don't enter this if statement, we just append that letter. And of course, after we append the letter, we have to make sure to put it back on our list with 1 fewer occurrence. And this is the whole greedy solution.